Alright, we're doing some calculus, and we are looking at integration. This particular one here, we're going to be doing some definite integration, and we're going to be using the method of u-substitution. So we're going to show that this integral here is equal to 1/6, and we're going to do that by u-substitution, because that's going to be the technique that we're going to have to do in order to evaluate this integral. Writing the integral out, we're going from 0 to 1 of x times 2x squared minus 1, that's quantity squared, dx. And of course we're trying to show that this is equal to 1/6. And that's not going to be too difficult to do. So we're doing u-substitution, and earlier we did u-substitution indefinite integration, but this is definite, means we've got so we are defining our bounds here. Usually what's in parentheses is what we always let be equal to u, and then we want to take the derivative. Du is equal to, so this becomes 4x, and of course that's 0 there, dx. And instead of writing du over dx here, we just go ahead and bring the dx up over here. So as you can see, we have an x and a dx, but we don't have a 4, and so we're going to want to write a 4 in here, and I'm going to do that with a different color. So we put a 4 in here, but we have to put the 1/4 outside the integral. Right? Must do that. Now we're going to go through and do part of this. There's something else we've got to do. I'll show you that here in just a second. So the 4x and the dx gets replaced with the du, and of course the 2x squared minus 1, right, we're going to replace that with the u times and then the du. Now there's one other thing that we need to do the substitution, and that is our limits here. So we're going to plug in 1. The way this is going to work here, you know, you can solve this u-substitution definite integration two different ways. You can go ahead and evaluate this without any limits, and then substitute the x back in like we did in the previous lesson, and then use these same limits here. But I think I find it just go ahead and doing the substitution for these limits, converting these limits over. So it's real easy to do. First thing we're going to do, and I'm going to label this as B here, right, because this is usually B and this is A. But all you have to do is plug this number in and get that out, and so that becomes a 1, right? So u b is 1, and then we want to do ua, and so this is 2 times, we're plugging 0 in this time, so this is 0 squared minus 1, and that becomes negative 1. Looks like a mu there. So we go ahead and write that in. So this is 1 and negative 1. Now we can go ahead and take this integral. So we have u cubed over 3, and we're going from negative 1 to 1. Right? Pretty simple. And if you'd like, we can rewrite this. This is u cubed over 12. Going from negative 1 to 1. Now we go ahead and do plug the stuff in. So 1 cubed over 12 minus negative 1 cubed over 12. And so we end up with 1 over 12. And then this becomes plus 1 over 12. And so that becomes 2 over 12, and of course that reduces down to 1/6, and there you go. Something that's interesting, you graph that's a totally different graph than this up here, and that's what's really interesting, is how this, if you looked at this as area, gets transformed. In this problem here, I've got one picked out, worked out, that doesn't have nice numbers. But in the real world, we don't have really nice numbers. Let's go from -7 to +7 of x squared and 1 minus 3x cubed raised to the 4th. So I just kind of like make this stuff up as I go and see what happens. So we're going to let u equal, remember usually what's in parentheses, 1 minus 3x cubed, and then our du, I guess I'll write it out here, is -9x squared dx. So just a real quick way of looking at this, look at this. If you take the derivative of the inside, you get -9x squared. Well, we have an x squared out here, but so we're just going to need to put a -9, and we can put a -1/9 outside, so there you go. And let's go ahead and convert our limits here. So let's do, we'll do the upper bound first, and this is 1 minus 3 times, we're plugging 7 in, so this is 7 cubed, and this number is nice and lovely. It comes out to be -1028, right? And we'll just go ahead and do the lower bound here. So this is 1 minus 3 times -7, and it is cubed, and we get a nice number, 1030. Right? So now we can do our substitution, except let me go ahead and write in up here in a different color. So we needed a -9, so we put a -9 in right here, and so that means we must put a negative, its reciprocal, outside. So now let's go ahead and do the substitution. We have -1/9 going from negative, I about forgot. Let's see, 1030. Wow. Almost made that mistake. And then we're going -1038, and then we do our substitution, so the x squared dx gets replaced with the du. We have u to the 4th du. So now we can do our integral, which is the easiest part, u to the 5th over 5, and we're going 1030 to -10 28. That should be a 2 there. Somebody probably said, wait a minute, that's supposed to be a 2. And then of course we can go through. Now I'm not going to work this thing completely out, but I'll give you the answer here. Let's just go ahead and write u to the 5th over 45. Let's just go ahead and do that. 30 to negative. And then, so we go ahead and plug our stuff in. We have it bringing the negative out, so we're going to have in parentheses -1028 raised to the 5th power over 45 minus, remember to start a parentheses, it's just good practice. And then let's see, our lower bounds 1030. We didn't have to put that in parentheses, but we ended up doing it anyway. Over 45. Oh, those are some lovely numbers. This is to the 5th power right here. So this negative's going to become negative outside, and that will make that actually a positive number. We can just get rid of the negatives then. 1028 to the 5th over 45 minus, and then of course we have a minus and a negative here. That's going to become plus 1030. So I said this is not going to be nice. Well, after evaluating this, I'm going to write this in scientific notation. This is 5.127, well, I don't know, we'll round it 3 decimal places here, times 10 to the, now I'm just approximating this, okay? This is just an approximation, times 10 to the 13th. You can get that all in one solid fraction if you want, or evaluate however you want to do it. Anyway, but this is what you should come up with, 5.127 times 10 to the 13th. And what this means is, if you don't know scientific notation, this basically means we're going to move the decimal place 13 places to the right. But then again, there's a lot of other, I cut it off to 7 right here, but there's a lot of other digits after it. It's not just zeros. But anyway, that's a good approximation. So there you go. Let's move on to another one. So we have the integral from 0 to 2 of 1 over the square root of 2x plus 1 dx out here. We're going to let our u be the 2x plus 1, because when we take the derivative of this inside here, what do we get? We get 2, but so we could write it 2 and then a 1/2 outside. Alright, du is equal to 2 dx, and let's go ahead and take care of our limits here. So we're going to plug 2 in, so we have 2 times 2 plus 1, and that's going to be 5. And then we'll do our lower limit, calling that use of a, so that's 2 times 0 plus 1, and that's just 1. Alright, we do the substitution now. Remember, we don't have a 2 up here, so we're going to write a 2 in, and therefore we must put a 1/2 outside. So there's our 1/2. Go ahead and write our limits in. So from 1 to 5 we are going, and this becomes 1 over, and I'm going to go ahead and get this out of radical form and just write it as like this, u to the 1/2, trying to save a step or two. We need to write this one more time before we actually take the integral of it. We have a 1/2 times, going from 1 to 5, of u to the negative 1/2, and ooh, I made a mistake here. That should be du. I'm sure someone saw that. Alright, du, not dx. So this becomes 1 over 2 times u, adding 1 to the exponent gives us a 1/2. Then we put the exponent down below, and we're going from 1 to 5. I start getting in a hurry and my handwriting starts getting worse. So we have a 1/2, and then we have a 1/2 down here, so that's going to disappear. So I'm rewriting this one more time. Right. So this is going to be a whole lot better than the last problem we did. And this becomes 5 raised to the 1/2 minus 1 raised to the 1/2. Well, we started with radicals. We should end our problem probably with writing our answer in radical form, and then that just becomes 1. So there is the exact answer. We don't have to approximate on this problem here. There it is. So that's nice. That's nice. Well, I think this is going to conclude some examples in solving definite integrals using u substitution. Right? Definite because we have limits here.